Welcome to today's Ask Tom office hours on JSON. In the past, we had a lot of database-centered sessions here where we talked about JSON table, materialized views, how to index JSON, etc. But if we look at JSON, there is this whole application development aspect to it too, where many new applications are created with JSON as this primary data model. And for this, we created the SODA API, the Simple Oracle Document Access API, where people can operate on JSON collections. They don't have to write custom tables and write complex SQL. Instead, they work with a NoSQL API. And today, we will look at this aspect of JSON, especially how SODA can be used with popular open source development tools or frameworks like React or Express. And today we have Srikrishnan Suresh here, short Shriki, who will present the SERN stack. Shriki, do you want to introduce yourself?
Sure. Thanks, Beda. So I'm Srikrishnan Suresh. I work for the JSON document database team at Oracle, and I'll be presenting SERN stack for web development.
Right. And we also have the pleasure to have Jeff Smith with us today. So he's a product manager for Oracle REST Data Services. And since the SERN stack also has a REST component in it, Jeff will explain us how Oracle REST Data Services can make our life a bit easier here. If you have any questions, please put them in the chat. We will have a Q&A at the end. And with this, I hand it over to Shriki.
Thanks, Peter. Like I mentioned, I'm going to present SERN stack for web development. So let's get started. So what is SERN stack? SERN stands for SODA, Express, React, and Node. I don't know if you're familiar with MERN stack. It's Mongo, Express, React, and Node. And SERN stack is Mongo React replaced by SODA. So SERN stack is a full stack solution for web application development. So in the modern world, systems are usually architected with a three-tier solution, wherein there is a database tier, a business tier, and a presentation tier. The presentation tier is world viewable, right? So if you're on a website, what you look at is a set of web UI elements on your web browser. So that is the presentation tier, and business tier is somewhere on the cloud, probably a middleware where all the business logic runs. And database tier is your database sits in the database tier. So that's where all the data is persisted. All the user inputs and are persisted in the database, and they are also fetched from the database when needed. So SERN stack fills these three layers. So React takes care of the presentation tier. SODA and Express would take care of the business logic layer in the middle tier or the business tier. And SODA is a database access API to access Oracle database. I'm going to be talking about SODA more in the slides to come. So you use SODA to access your Oracle database, and with JSON as a primary data exchange format. So introduction to simple Oracle document access, or SODA. It's a set of NoSQL style APIs for managing document collections in Oracle database. Documents are usually in JSON format, but we support non-JSON format as well, like PDF, XMLs, and other binary format. So if you're a NoSQL programmer, you could use SODA to access JSON documents in Oracle database. They are stored as collections, and SODA offers easy to use NoSQL style APIs to access managed collection documents, index them, and so on. So that does not mean that we are turning off the SQL knob. You could still continue to use SQL to access your JSON documents in the Oracle database. So you could use SQL for reporting and analytical operations on JSON documents. So more about SODA. SODA terminologies. A SODA document is analogous to a row in the relational world, and similarly, collection maps to a table in the relational model. So when you create a SODA collection using SODA APIs, A table is actually created in the Oracle database. And similarly, when you insert a document into a collection, you insert a row into that backend table. Collections reside in a database, which is analogous to schema in a relational model, and you can perform CRUD operations on document collections. By CRUD, I mean create, remove, update, and delete. Usually operations are driven by keys. If you want to find a document using a key, you specify the key string and retrieve the document. And you could perform more complex queries using QBEs. QBEs stand for query by example. I'll be showing you examples of QBEs a bit later. This is just to introduce the basic SODA terminologies. So to reiterate, a document maps to a row in the relational table and collection maps to a table. So if you create a SODA collection, behind the scenes, we create a relational table. When you insert a document into that collection, we insert a row into that table. So end of the day, it's just a relational table, but SODA offers a nice NoSQL style interface for the users to interact with Oracle JSON database. So each SODA document would typically have the following components. There is a key and there is a content, which is typically JSON, but you could have non-JSON documents as well, as I mentioned before. And there are two timestamp fields, created on and last modified. Created on tells you when the document was created in the database, and last modified is when the document was last updated in the database. And there is also a version which maps to, it usually is a function of the content, and it could also say when the document was modified. It's used to do optimistic locking. And as I mentioned before, underlying table backing the collection would have one row per every document. So here is a table in the Oracle database. You can see that it has 5 different columns. Each of the attributes in the document maps to a column value in this table. So if document has a key, it goes on to the primary key ID column, and the content, which is typically JSON, goes to the content column, the version created on and last modified, and so on. So when you insert a document into a collection, a row is being inserted into this table, and we record the created on and last modified time. Similarly, when you replace a document or update a document, the last modified value is also modified, and the version also gets modified as and when the content gets modified. So what is SODA in the context of SERN stack? So SODA occupies the data access layer in the stack. It's used to access the data in Oracle database. The interface is predominantly JSON. So I'm showing you 4 different examples of insert, replace, find, and remove. In the first example, you see that we create a JSON document. It's a SODA document with very simple JSON object. It says name is Alexander. You create a document and you insert the document into a collection using insert one and get method. It's a method on the collection object. Similarly, for replace, you call replace one and you supply a key. So you're saying here that I want to replace the document that has key K1 with this particular JSON object. And similarly, to do finds, you supply what is called as a QBE, which is query by example. Here you see a very simple QBE, but it could get very complex with several operators. We support comparison operators, logical operators, so on and so forth. So here you say collection.find.filter of QBE. You supply the QBE and get me the top document in the result set. So this would return just one document, the top matching document. And similarly for remove, you supply the key and you call the method remove on collection.find. So you say collection.find.key, you supply the key and you say remove. So if this key is not going to be specified, it's going to remove pretty much all the documents in the collection. It acts like truncate. So you can see that The way the code is written is very elegant and very simple. You do not have to write complex SQL queries with binds and bind values specified. Soda takes care of binds and executing the statement. If you're coming from the SQL world, it sometimes gets tricky to issue binds and the bind values and execute the statement, but Soda abstracts all that complexity. So the Soda is available in different implementations. It's available in PL SQL, it's available in C, Java, Node.js, Python, and REST. The examples that you see on the screen are for Soda Node.js. We are going to be focusing on Soda Node.js in this presentation. So with CERN stack, you will actually see that the language used is JavaScript all the way in the stack, right from Soda to Express to React and Node. It's all JavaScript based. Moving on to the next element in the stack, it is Express.js. Express.js is a server-side web framework for Node.js. It offers various HTTP utility methods to map an incoming HTTP request to a Node.js function. So this typically runs on a backend server, and depending on the REST URL, Express maps that URL request to a Node.js function. So the code to get started with Express.js is just this much, what you see on the screen. It's very simple. This is all you need to start an Express.js server. So this listens to REST requests at port 3000, and it maps the URL request employee to this Node.js function. And this function returns a JSON object as the HTTP response. So when you call app.listen, it starts listening to requests at port 3000. So what does Express do? It requests, it receives requests, HTTP requests, it processes the request and sends an appropriate HTTP response. So that is the responsibility of Express in CERN stack. Moving on to React. React is on the presentation tier, like I mentioned before. It's used to develop UI components that are rendered on the web browser. It uses it's a stateful component-centric development framework. It was developed by Facebook. I think Facebook relies on React for rendering the UI elements. So it is really component-centric. So when you open your Facebook page, you would see a bunch of posts and probably a set of comments below those posts. So whatever you see on the page, starting from a post to a comment, etc., they're all seen as components by React. And each of those components would have state information. So as and when the state changes, the UI is refreshed automatically. So that is the job of React. It maintains a state, and when the state information changes, you would see that it would trigger a refresh on the UI as well. So if you add a comment, the state changes and the UI also changes. So it offers nice event management facilities. You can attach listeners to your UI elements. You can maintain state. You can also update the state when you want. It's coded in JSX. It's just a syntactic extension to JavaScript. So here is a nice example of a code that you would write using React. So what would you call this? Is this a string or is this JavaScript? It's neither, it's JSX. So you will see that an HTML element is assigned to a JavaScript variable. So this is how you write code if you're using React. So this is written in JSX. So similarly, here is a function which returns an HTML element. So it returns a div element, and it has a few heading tags below it. And what you see inside the curly braces are the model information. So React receives a JSON object as response. So in this stack, it's given by Express. So using the JavaScript object, you render this div element on your web browser, and you say that the name of the employee should be with heading 1 tag, and the title should be with h2, the heading 2 tag. And employee is a JavaScript object. It has various fields like ID, name, and title, and you render them using these tags here. So whatever is inside the curly braces is actually, you can see them as JavaScript code. So you'll also see that I've managed to add class information. So that's how you associate an HTML element with CSS attributes. So this div will carry this class name for the CSS. So here is the interaction view. So where do Express, React, and Node and Soda fit when I architect a system? So I have my database running here in the database tier. I'll be using Soda Node.js for accessing the database. It also lets you manage connections to the Oracle database. And JSON is primarily the interchange format. I use Soda to query the database or to update the database. And React is going to send HTTP requests and wait for a response. The HTTP requests and response are managed by Express.js. It opens a REST listener. It listens to HTTP requests and forwards the requests to Soda when it wants to query the database. It might have some business logic as well, could get quite complex. And after the processing, it returns an HTTP response to the client. So React takes care of event handlers. It renders UI elements. So React actually doesn't care how the backend server is architected. It could be using Python or Node.js or even Java. All it cares is the response that it gets from the HTTP endpoint or the REST endpoint. And once the JavaScript object is available as a response, it uses them to render the HTML components. And it also takes care of managing its state information, and it processes the events when needed. So React is on the presentation tier because the response it's an HTML response which runs in a browser along with JavaScript code. It builds an in-memory DOM, and anytime the DOM changes, the state of the DOM changes, the UI is also refreshed automatically by React. So that's the big picture. That's to say how each of these elements sit in the three-tier architecture. So to a quick recap, there is presentation tier, business tier, and database tier. Soda and Express would be in the business tier. And it takes care of processing the business logic, and React takes care of rendering the information on a browser using as an HTML. So I'll quickly walk you through model view paradigm. I'm sure you're familiar with this, but in the context of SERN, model could be a JavaScript object. So consider an employee, a real life entity. It is represented using JSON, as you see on the screen. So an employee has a bunch of attributes. He has an ID, name, phone number, etc. So the UI decides how to render this data that is world viewable. So here is an example. Just consider this as an HTML page wherein there is a name, employee's name, his salary, etc. So all the UI needs is a JavaScript object. So once it receives a JavaScript object, it decides how to render them on the web page. So with this information, we are going to build an app. This app is called MuSprint. It's a web application designed to track sprint user stories on a storyboard. I'm going to quickly show you a demo of this app before we see how the app can be built. So I'm gonna, right. So this is the app. So you see, it's a very simple app. There are 3 panes. It's a storyboard with 3 panes. There is a to-do list, there is an in-progress list, and there is a completed list. And each of these panes would have a list of user stories. So this is, each of these stories are used to track a task for your sprint. So you could first start adding an element to the to-do list, and as and when you complete it, you switch to another category. So it's a very simple web application that was built using SERN stack. So you could edit the user stories, you could perform CRUD operations on user stories, you can delete them, you can add a new user story, and so on. So that's what this app does. So I'm gonna get back to my presentation now to see, to tell you how this app was built. So we formed 3 teams. So there is a UI team, there is a services team, and there's a data team. So the UI team will manage the user interface. So whatever you saw on the web page was designed and developed by the UI team. So it will manage the user interface using React.js framework. And all it needs is a set of REST endpoints. So to do CRUD operations on REST, to do CRUD operations on user stories, it needs certain REST endpoints. So it needs an endpoint for adding a story, for deleting a story, for updating, and so on. So like I mentioned before, the UI team does not care how the backend service is implemented. All it needs is a JavaScript object as a response to the HTTP requests that it sends. So it would send an HTTP request for fetching the user stories, all the user stories that fall under a given category. So the REST endpoints are managed by the services team. It will expose the REST endpoints on the backend server and open the listener. It will use Express.js to do it. And it will need APIs from another team, which will be the data team, to manage JSON documents in the database. So this team, it knows how to map an incoming HTTP request to a Node.js function, and it would call certain functions to persist the data in the database, and similarly to fetch the data from the database. So therefore, this team actually is not database aware. So it doesn't care if the data is actually coming from an Oracle database. So all it needs is a set of APIs to manage those JSON documents. It would feed in JSON documents, and it would ask the data team to persist those documents in the database, and similarly to fetch those documents back from the database. So this team is not connection aware. It has nothing to do with the database. So that is managed by the data team. So it manages connections to Oracle database. It could typically create a pool of connections for performance reasons. And it will provide interfaces for managing JSON documents in the database using Soda. So this team takes care of issuing Soda calls for fetching and updating documents into the Oracle database. So the 3 teams sign a deal and start their development. The UI team starts its development of web interfaces. It would probably start with a mock UI, but it says that it needs user stories. So once the user stories are available to them, we know how to render them on the web page. So it uses React.js to populate the div elements. So each of the little boxes that you see here maps to a JSON document. So if on the UI, when you update this document, it's going to eventually send an HTTP request to update the document and eventually put that document into the database. So similarly, on load of this web page, it needs to fetch all these documents. So in that case, it would send a HTTP GET requests. So once it receives a JSON object, it knows how to render those UI elements. It takes care of CSS, it takes care of client-side events, and it also takes care of sending the HTTP request to the React server, or sorry, to the Express server. So here is a JSON document that represents a user story. So like I mentioned before, each of the documents that you see here maps to a JSON or a JavaScript object. So here is an example of a JavaScript object for a user story. So there is an ID field, there is a type, there is points, the number of points for this user story, and so on. There's a description. So using React, you can decide how to render this div once you have all of these fields. So you'd probably say, hey, the title has to be bold-faced and description has to be paragraphed, etc. And here is an example of rendering that UI component. So this function returns a div element. So the highlighted one here is a div element. It could of course have child HTML elements as well. So in this example, there is a span element, there is a paragraph tag, there is H5 and H6 and so on. So there are some class attributes attached with some of these HTML elements. And you would see that inside the HTML elements, the information, the story information is being rendered. So here we say this dot state dot story dot points. So with React, you maintain state information, and each of the div has a state. That state is another JavaScript object, the object that you received as a response from the Express server. And then you render title, subtitle, and description. So this is how you would typically write a JSX function to return an HTML element. And you could also have event handlers. For instance, if there is a button, you would want to say what happens when you click that button. So typically you would refresh the state. For instance, if there is a delete button, you remove a particular user story from an array. That array is persisted as a state. Like I mentioned before, it's a DOM. So you remove an element from the DOM, and you would see that the div element disappears from the web page. So that's just what happens on the client side, but eventually you would also have to send an HTTP request to the server to delete that document from the database. So for that, you'd have to send an HTTP request. So moving on to the work done by the services team, it offers a set of REST URLs. So in this example, it offers a GET request to fetch all the user stories of a given type. It also offers a POST request to add a new story, to add a new user story. The input is in the form of response, in the form of a request body. Similarly, there is a PUT request. You could use this PUT request to update a user story given a key. So the ID you see here is a request parameter. So you say, hey, I want to replace this document that has this ID with another document. And similarly, you could supply an ID and say you want to get that document removed. So for that, you use an HTTP delete request. So these endpoints are exposed by Express. Here is an example of a PUT request. So it receives a request, a PUT request, and it receives an ID as a request parameter. It also receives the story as the request body. So if you see here, it says key is request.params.id, which means that it is fetching this ID that is part of the URL, and it's also reading the request body, which is a user story. So it wants to update this document that has this key with a new user story. So you would see that this code calls another function, replace story. It passes on the key and story. So this function, replace story, would use Soda to update the document into the Oracle database. So this is an example of a REST handler. I'm now showing you an example of insert using Soda. So this request was this function was requested by an Express function, right? Like I mentioned before, here is a REST endpoint. So this function is mapped to a REST request, and it forwards the request to this layer to issue the Soda calls. This is just to have a layer of abstraction, because this REST handler, as per this design, is not connection aware. It doesn't know how to use Soda. It receives a request and it knows how to process the response. So it relies on this layer, which uses Soda to manage connections and put get documents from Oracle database. So it opens a connection to Oracle database using this call. So the line here says await Oracle DB.get connection. So this is to obtain a connection handle from the pool, and we use that connection handle to open a collection handle. A collection handle is it's a handle to a Soda collection, and it's bound by a connection. So you use a connection to open a collection, and you would insert a story into that collection. So here you say await call dot insert one and get. So you feed in a story, you wait for a response. This is insert one and get. So what this function does is it inserts the story into the database using the connection, and it sends back the response. So the response would be a document again. The result that you see here is also a Soda document, and it has a populated key, the created on and last modified, and the version fields. Key could be either client assigned, wherein you supply a key and say how the document needs to look with a key, or you could rely on Soda for generating the key for you. So it could either be client assigned keys, or it could be something like UUID assigned, which is generated by Soda. So when you call insert one and get, it returns the other fields of the document, namely ID, version, last modified, and created on. And in the finally block, we release the connection back to the pool. So we say connection.close. So all the examples that you're going to see from now on will have a very similar template, just that the Soda call is going to change. So the way to get a connection, to open a collection and close the connection, is pretty much the same. So I'd like to show you an example of get stories. I open a connection again and a collection, and I'm going to use the QBE to filter documents in the collection. So I want to retrieve a set of stories that fall under this category. So I use the type field in the user story. So if you get back to the story JSON document, few slides back, it's going to have a type field. So for this story, it's under the completed category, which falls under the third column in the UI. So I want to say, I want to fetch all the documents, all the user stories that are marked complete, right? So for that, I use this QBE, and I say, hey, fetch me all the documents that are of this particular type. So the type is passed in as an argument to this function, and I say the QBE is this JSON document with this type. Or if the input is all, which means that I want to fetch all the user stories, then I don't need to apply a filter at all. So the input is actually an empty JavaScript object. So the next line is the one that actually performs a round trip to the database. It uses the collection object to call find.filter. It sets the QBE, and then it calls get documents. So this API, this get documents function, returns an array of JSON documents. So in this case, it's going to return an array of user story documents that are marked with a particular category of type T. Similarly, remove, you say collection.find.key.remove. And for replacing, you use the function replace one. So you set the key and you say replace the story that has this particular key with this new document. So for replace, a key is a must. You always replace with a given key. That's not the case with remove. You can actually remove n number of documents in one round trip. So the key is optional for remove, but is currently mandatory for doing a replace operation, meaning that you can't do a mass replace using Soda currently. So that said, I'm going to walk you through a GitHub repository code base that was used for MuSprint app. So I hope you see my screen. So it's on this page. It's an Oracle JSON in DB. The link is there in the presentation. And
maybe you can copy it to the chat so people can copy it out and store it. Thank you.
Of course. Let me get the chat here. All right, chat is.
You can do it later. Just oh, there it is.
Right.
Cool.
So the GitHub project, the link is here. So you could go through this. I'm going to walk you through some of the folders inside this project. So as you can see at the top level, it's a MuSprint project. There is a client directory and there is a stories directory. So the client is, it has all the code that is required to render the UI. So as you can guess, it's going to use JavaScript, React to render the UI elements. And then stories is going to have the Express.js code and also the Soda code. So you can see this as the presentation tier and the stories as the business tier. So I'm going to get inside the stories directory. You can actually look for the documentation here. It says the REST endpoints that are available for consumption. So the one that we just saw in the slide. So I'm going to open the Express.js code. It is in router controller. So this is the front end code for Express.js. The code that you see here is a lot more than the one that you saw on the slide because it actually does a lot more. So it's going to register a listener. It's going to register a function callback for terminating the application. What happens when you issue a SIGINT or a SIGTERM for this process? So all that code is here. Here is the main part. So it says forward all the incoming requests to this URL, to the URL/stories, to this JavaScript, to this Node.js module. So we need to be looking at new story module, which is inside core stories. So if you go inside core stories, you would see all the mapping that starts with this URL. So any URL that begins with /stories would be routed to this Node.js module. So this is how you this is how you write Express.js code. So let's get inside this directory, new stories. It's inside core stories. Right, so here you would see all the mapping requests. So this function is used to map a GET request, and the argument it expects is a type. So it expects a GET request for all the user stories of this particular type. And you can see there's a try catch block in the try block. We read the input, the request input. It's in the form of a request parameter, right? So you see here :type. So it reads request dot params dot type, and it calls this function dao.getStories. I'll be entering this function also a bit later, but this function is going to knock the database door to fetch the user stories. So you can see that this layer manages the REST endpoints. It manages the request URLs, the parameters, etc., the response body, and it's not connection aware, like I mentioned before. So this function is going to wait for a response from this JavaScript function, from this Node.js function. This is an async function, so that's the reason we put await. So it's going to wait for this function to return back, and once we have a response, we are ready to send it as part of the HTTP response body. So the next line says response.json, and the JSON to be written as the response is the docs that we just got. So that is a GET request. Similarly, post, which is an insert, is going to call insert story. It's going to wait for a response. It's very similar, just that the function it calls is different. the HTTP method is also different. So for reading, we used a GET request. Similarly, for adding a collection, for adding a document into the collection, we use a POST request. So if the request is a POST, then you read the request body, which will be a user story. So the user's intention was to insert the story into a collection. So you pass on that story as argument to the insert story, which would again go to the database to persist that story or to add that story into a collection. So there is a put request and there is also a delete request, the ones that we just saw in the slide. It's very similar, just the function call is going to be different. It forwards the request, it reads the request body, etc. And it forwards that JavaScript information to this function and waits for a response. And once the response is received, it moves ahead with setting the response. So in this case, there is it's either success or a failure. So if it succeeded, it's going to send back HTTP code 200 as a response. And delete is also going to do the same thing. It's going to say the HTTP response is 200, which means that the story that you wanted to remove, it was done successfully. The operation was successful. So let's now get inside this function. So DAO, what is DAO? DAO is data access object. It's just a module name. So as you can see from the header, DAO is inside the DAO directory. So let's get inside that directory. And so this layer is going to manage Oracle connections. It's going to use Soda to do document puts and document gets. So here is a function that gets all the stories of a given type. So this is the function that was called by the other Express.js routine. So that was a GET request, and that request was forwarded to this function. So you'll see that in this layer, there is no reference to HTTP request or response. It received a request in the form of an argument, not an HTTP construct like request body or anything of that sort. So you're given an argument of type. It's just a JavaScript variable, and it returns the result after it contacts the Oracle database. So it's going to, the one that we just saw in the slides, it's going to get a connection, open a collection, and you use this QBE to filter the documents of this particular type. So it says collection.find.filter. You filter based on this QBE, and you call get documents. So what does Soda do for you when you call get documents? So Soda is going to interpret this call, and it's going to translate that into a SQL query. So Soda is the layer that offers this abstraction. You actually do not know the actual SQL query that was constructed. So it generates a SQL query, which would look something like select ID, ID, comma, document, comma, all the other fields from the backend table, where it uses a where clause and a function called JSON exists. And it uses something called a path expression and filter predicate. So it constructs this entire query based on your QBE. So all that work is done by Soda. So you can see that it's extremely easy to use, and it offers NoSQL style for interacting with Oracle database. The JSON, the data model that we use in the database is still pretty much relational. It's not JSON, but given this QBE, Soda automatically translates this QBE into a JSON exists clause, which it would be the where clause in the SQL query. And that statement would be prepared. It would issue the binds. It would execute that statement and return back the response. So that's Soda get. I'll show you an example of Soda put. It's an insert. So you'll see that there is this function call await call.insert1 and get. This would translate to an insert SQL. So this would translate to an insert query. Or it would be something like insert into this table. It would use the values clause and the bind variables. It will issue the binds and execute that statement. And once the insert succeeded, it's going to return the document attributes. So that's with Soda insert one and get. Similarly, there is also a function for replacing. So like I mentioned before, you use a key to replace a document, and you use, so in this example, you also use a key to remove a document. It's strictly not needed. You can remove an array of documents from a collection. But in this case, this function is triggered when you click on a delete button in the UI. So you will see that there is a delete button here. So when you click this button, it's going to send an HTTP request to Express.js, and Express.js will receive a delete request. So it's going to, that Express.js, the Node.js function that's mapped to the HTTP request is going to call this function and pass in a key. And this function is going to remove the document that has this particular key. So that's done by this line. So it says await call.find.key.remove. So I hope with this you get a full picture of CERN stack on how the user actions reach the server and how the server reacts to an HTTP request and forwards the request in terms of a Soda call. So I hope the entire picture was clear. So just to recap, let's say I click on a delete button. It's going to, so when I click on a delete button, you see a modal here. And when you do a confirm, it's going to send a delete request to the backend server, which is coded in Express in this case. That would be a delete request. It passes in a key. You remember that React knows the JavaScript object that was used to render this div element, right? So it used the JavaScript object to render this div element. So it also knows the key. It's part of the state information. So it uses that key to send an HTTP delete request. That request goes to the Express server. It knows that it has received a delete request, and it maps that request to a Node.js function. It reads the HTTP request body and the params. In this case, it's the ID. It forwards that ID to the other function, which issues the Soda call to the database to remove the document from the collection. So that's the end-to-end flow. I hope that was clear. So if you have any questions, please feel free to put it in the chat. Going back to the presentation.
So Shriki, there was let's give Jeff a chance. He wants to speak a bit about this REST part because he has to leave. So maybe we can do a little break and let Jeff speak to how ORDS could also fit in here. Mm-hmm. There was a part where I think it was called routing this table, where you wired up your REST request with functionalities, and you had these error codes and this stuff. And I think ORDS, Oracle REST Data Services, can do something here. Is that correct, Jeff?
Thanks, Beta. Yeah, so I almost feel like I'm a JavaScript expert now. Thanks for that, Sriki. It was really good.
Yeah.
So the database team makes a sort of web listener available for the database. So your applications can use HTTPS to get things in and out of the database, basically, not to dumb it down too much. HTTPS is ubiquitous. It's everywhere. Any programming language and interface and framework works with it. And obviously that's very popular with JavaScript. And of course, we always use JSON as that communication vehicle to transfer the data back and forth. So what our technology does, Oracle REST Data Services, is it allows you to, in the mid-tier, have the REST services defined and running and available to you for your application stack. So you could do exactly what Srinky showed us today and in the Express side have a portion of the code running, but anything where it was dealing with like opening connections and managing status codes and implementations of the REST handlers or the APIs, ORDS handles that for you automatically. So if we were to look at, what page was that? This page here, where the services team is responsible for making these APIs available to the app devs. With Oracle REST Data Services, there is a SOTA for REST API out of the box. So the mid-tier automatically knows about all of your collections, and it automatically has templates and handlers available for all of those collections and all of those documents. So anytime you need to batch load, say, an array of documents as new items in that collection, that's a single REST call. You don't have to write any code behind that REST call. You just make the HTTP request and you set up the headers and the request body, and all of that mid-tier code is already there for you. And the response is going to be the appropriate 201 or 200 or a 400 if you do something wrong, and all of that code is written for you as well. So you have a full CRUD interface for all of the JSON in your database. And of course, Oracle likes to give you 10 different ways to do the same thing. So even if you're storing JSON documents as a column in a relational table, our REST APIs handle that scenario as well. But if you want to stay with the pure JSON document store model, like what this SERN story is doing, then we give you all of the endpoints that you need to implement that. So regardless of what JavaScript framework you're using, you could use the Oracle Jet one, for example, which is what Oracle gives you as a preferred platform when you're in the Oracle Cloud, for example, or React, or there's what, a dozen or 2 dozen JavaScript frameworks out there. Or maybe you're not doing JavaScript at all. Maybe you're doing Python or simply curl for automation, or
Right.
those REST APIs are going to be there. So you're going to be able to interact with the JSON in the database. You worry about what you want the document to look like. You worry about what the document is going to look like once it comes down into your app and how it goes back. And you just call these APIs that we give you.
So is it fair to say if you start with a new application, you can think about using either Express and do it the way that Sriki has shown it, or to use ORDS?
Absolutely. Yeah. I mean, so if you're a JavaScript gearhead and everything you saw Sriki do today just like tickled you, and you're like, oh, this is awesome. Yeah, you have that entire SOTA library available there in Node. If some of the backend type stuff was like, yeah, I'd rather worry about my widgets on the screen and worry about the presentation of the data, and I want something on the backend that Oracle gives me to manage that for me, then what I'm talking about is available. And of course, there's also hybrid model too. So you could use a lot of the Node stuff and just leave the pure database interaction to
I think actually the more I think about it, it's not really an either or question. So you could have some logic that you want to execute in the database. Let's say you are you know how to write PL SQL and you want to push down your code at the bottom to your data. You could do that and expose that using ORDS. But at the same time, if you want to make some transactional changes, let's say do updates to multiple collections, that would be harder to do over REST because REST is stateless. So there you had a benefit of using the SOTA for NodeJS driver that Sriki was using here, right? So it's really depending on your use.
There's no right or wrong way. I mean, most development shops will go with the tools and platforms that their skill set already exists for. I mean, we ourselves have built our own web application using the SOTA REST backend for when you're dealing with SOTA documents in the Oracle Cloud. So this nice slick UI is all JavaScript, and all the communication with the database is using the ORDS SOTA for REST. And it's the exact same QBE syntax that you would use in SOTA for Java.
So this is then, so going back to the big story, this is then really a task of a back-end developer to figure out, when do I need transactions? Do I use NoDriver or do I use ORDS? But for the front end person who writes these JSX files, they don't have to know anything about this, right?
No. Yeah. You would send them the Swagger doc. Here's your APIs. Go play.
Yeah.
And you could care less how they're implemented.
And then you could even,
as long as they're implemented well. If they're slow, they're going to care.
And it sounds then also possible to replace things in a not too complex way, right? You could say, well, this REST call is now implemented differently because I don't know why. It has to do some more business logic or transactional changes, and nothing has to change in the front end code. That's correct, right?
Yeah, I mean, you can really play with things like URL rewrites and load balancers, and really do tricky things where you're changing stuff and there's no visibility of that to the.
Yeah, I know very little about UI and all these latest frameworks, so I learned a lot from this today. Thanks, Ricky. So if someone wants to play with this, you've already shown it's on GitHub. I put the link in the chat so people can copy it out. What do people have to do besides going on GitHub? Do they have to get the instant client, or is this described on the GitHub page as well, how to?
Right. So there are deployment instructions on the GitHub page. You would need to install Node.js. You would need an instant client. When you use an Oracle database on the cloud, you would need a wallet. So all that information is on the GitHub page. There is also a Docker file if you prefer using a Docker.
Oh, great. Okay, cool. So people don't need access to an on-premise database. They can just get a free cloud account and get going.
Right.
Great. And you implemented all this yourself, right? You talked about 3 different teams, the UI team, the data team, the REST team. Right. You did everything yourself, right?
That's correct. But ideally, the app could be quite complex with a lot of other capabilities. So the teams would want to divide the work amongst themselves.
Great. So we have a few more questions. Jeff, I know you need to run. All the questions, I think, are SODA related, so feel free to drop off. Thanks a lot for joining us today.
Thanks for letting me butt in.
Yeah.
Thanks, everyone. Have a good week.
Hopefully we repeat this one time again. This was good.
Thanks, Jeff.
Yep, thanks,
and
Ricky.
The question we had where, so there was one question, I believe these were not necessarily CERN questions, but rather SODA questions about updating parts, or it was called update object or array of a document. I think you've shown like a full document replacement.
Replace, right.
And you also explained very well that the SODA is a layer on top of the database that rewrites these SODA operations, like this query by example filter, into an equivalent SQL operation. So you say, I want all the documents where the type is X, and under the cover, without you knowing it, the database would see a JSON exists. It would never actually see these operations. And you also explained that with insert.
Right.
So for update, we have various ways to update JSON data piecewise, like we have JSON transform, we have JSON merge patch. You can write PL SQL code to do an update. So what options do people have in SODA as of today?
Okay, I think that's a very good question. Currently, there isn't an update function in SODA Node.js.
Right.
All you can do is do a full document replace. Unfortunately, update isn't available yet, but we are working on it.
Yeah, exactly.
So in the meanwhile, they could use JSON transform or JSON merge patch, or they could build a DOM and manipulate it.
So right now, exactly.
And I think since this is SODA Node.js that we're talking about, you could use Node.js to write JavaScript code that could update your content, and you could then call replace. So those are the options that you have currently.
Exactly.
That said, we are working on an update functionality. It's going to, it might be available soon.
Yeah. So it would also be possible to, it's again, it's a workaround to have your update code, let's say a JSON transform statement, or if it's more complex, you write some PL SQL business logic, you register this as a procedure or a function in the database and then expose it using ORDS. So you could even make REST call that performs an update, but it would look a little different in the syntax because the SODA update syntax, which similar to QBEs, is not out yet. Yeah.
Right. It may not be the one line that we saw in the other examples.
Yeah.
Exactly.
Good. I think we answered all the questions here. I don't see any open questions anymore. So with this, thanks a lot for staying, and we will upload this with some descriptions and time pointers to YouTube. And if you want to see it again or look at some steps, you can find it on YouTube in a few days, hopefully. So thanks a lot, Sriki.
Thank you, Beta.
And thanks everyone for joining. See you next time. Bye.
Bye.